We are live. Live, I tell you, live.
It's alive, and by it, we mean us.
Yes.
Let me first start by saying that jet lag is stupid and it sucks, and I think there ought to be a law.
So
We
you
are live.
were
We
places
are
that are
live.
quite
Live,
north.
I tell you.
It's alive, and by it, we mean us.
When solar.
Let me first start by saying that jet lag is stupid and it sucks, and I think there ought to be a law.
The show going. Hold on.
So
We
you
are live.
were
We
places
are
that are
live.
quite
Live,
north.
I tell you.
It's alive, and by it, we mean us.
How did I get here?
Solar.
Let me first start by saying that jet lag is stupid and it sucks, and I think there ought to be a law.
The show going. Hold on.
So
We
you
are live.
were
We
places
are
that
live.
are quite
Live,
north.
I tell you.
It's alive, and by it, we mean us.
How did I get here?
Say we're
solar.
live. Let me first start by saying that jet lag is stupid and it sucks, and I think there ought to be a law.
The show going. Hold on.
So you
Fix it.
were
We
places
are
that are
live.
quite
Live,
north.
I tell you.
It's alive, and by it, we mean us.
How did I get here?
Say we're
solar.
live. Let me first start by saying that jet lag is stupid and it sucks, and I think there ought to be a law.
The show going. Hold on.
So you
Fix it.
were
We
places
are
that are
live.
quite
Live, I tell you.
It's alive, and by it, we mean us.
How did I get here?
Say we're live.
Okay, hold on. Now, what the hell is going on? Stop. Just stop. Ah. All right. I think I got it turned off. They can't hear you yet. I just turned off everything because I don't know what the hell just happened. I can't hear you. Hold on. I still can't hear you. They can't hear you. No one can hear you because yeah. Oh man, that was horrible. Okay, I think I can hear you. Say something. Yeah, so let me add your audio in carefully. Very, very carefully. I created audio inception. Say something. Yeah, so let me add your audio in carefully. What's going on? Very, very careful. Where? Okay, I found the window. I found it. I have now killed it. So now let me add your audio in. All right. Say something.
Can you hear me now?
Yes. All right. And
Okay.
it's not repeating.
And that's how you make sausage. Yeah, so we went to Iceland and then Amsterdam, and so we arrived at Iceland. On the day we arrived at Iceland, as we were flying in at night, and we went over Greenland and we saw auroras, which was just amazing. My kid had never seen auroras before, and so it was working perfectly. Then we landed in Iceland, and the day that we got there, I checked my news, and the most powerful solar storm since 2017 had been
Yeah.
unleashed. Was it like an X9 flare? And so we hunkered down and got ready, and then we had a tour where we did this big long bus tour where we were going to come back at night, and I'd hoped that we'd have clear skies and be able to see it. And yeah, coming back, we saw this amazing purple and green across half of the sky, and we stopped at this incredible waterfall in just incredibly dark skies and watched the auroras dance. And they were great. They weren't as great as the one that I saw back in 6-7 years ago.
Yeah.
And apparently it's because when the solar activity is really strong, it actually goes farther south and avoids the northern parts. And so people in California and New York and you would be seeing the auroras, but in fact the stuff that would normally be up at Iceland was now much farther south. And so they were good, but they weren't great. in the way that I've sometimes seen them, where they blow your mind. You can't
Yeah.
believe what you're seeing. So, but still, it was great. And and my kid had never seen the aurora, and so it was just great to be able to kind of share that with them.
This was kid one?
Yeah, kid one, yeah.
That's
So
awesome.
yeah, and it's funny because the kids were talking and they want to swap trips now. So the younger, who we went to Japan, he now wants to go to Iceland and and Amsterdam. He's obsessed with city planning and walkable cities and biking, and really wants to see what it's like to be in a place like Amsterdam, where everyone takes cycling so seriously. And so we'll probably do like a bike tour around Amsterdam. And then the other one, yeah, like I've been raving about Japan, and so they want to go to Japan, and so we will, I'm sure next year I'm just going to do the same trips that I did, but swap kids. And I'm sure you're wondering, like, why don't you take both? But there's something special about just traveling with one person, that there's a kind of a dynamic that gets set up between two people or three people that you just don't get. And so, like, I spend lots of time with both of them, but I love to be able to do sort of one adventure a year with each one, to sort of, there's this really kind of sad thing that you learn, which is that when you leave home, you've already spent 90% of the time with your parents.
Yeah.
That you will for your whole life.
Yeah.
And I refuse to prove that out. I spend a mountain of time with my kids every week. They're kind of like my best friends. So, and hopefully I'm one of their best friends, and this is sort of one of the ways we share. So anyway, back, but man, jet lag sucks.
Yeah,
sucks. And there's like,
really
it never gets better. And you always think, oh, I'm gonna sleep on the plane, and then I'm gonna stay up, and then I'm gonna go to bed at what is the normal time to go to bed in the place where I've arrived. Nope. You're exhausted in the middle of the day. You wake up at 3 a.m, and it lasts for a week, and then you're finally back to your normal schedule. And so I'm 3 days in and waking up at 4:30 now. So I'm getting there.
Oh man.
So we got to do the show. Shall we rave about Starship and Europa Clipper at the end? Yeah, you know what? That's your dessert. First, everyone, you've got to eat your vegetables, and then we'll squee about rockets.
The Starship one is, I spent all last week saying, I'm so confused. And I will explain that also at the end of the show.
All right. No problem. Yeah.
All right.
So just buckle up and learn about the Swift Telescope, and then we will, get giddy and talk about rockets.
And are we not going out on Twitch?
I don't know.
I don't either is the problem. Oh, that's my personal Twitch. No, we're not going out on my personal Twitch. Let me open up the correct Twitch account, and then I'll be able to see any comments coming in. And I'm going to do this very carefully. If only it was only twice. All right. Stream manager. There we are. Yes, we are live on Twitch. All right. I feel better. You have YouTube.
Okay.
I have Twitch. We do not have audio inception.
Okay. You ready?
I am pressing record on the audio.
I'm also pressing record
on the video. We are recording.
All right. It is episode 730, right?
Yes.
Okay.
It is.
All right. Astronomy Cast, episode 730, the Swift Telescope. Let me do the full name. Okay.
Sure.
Because that'll make more sense when people see who we talk about next week. All right. Astronomy Cast, episode 730, the Neil Gehrels Swift Observatory. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today, and with me is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well, but I am very tired because our sky keeps doing weird stuff.
Stuff that needs to be watched.
Yeah. So we've had aurora. There is now a comet that, like, you can get amazing photos with a 10-second exposure on your phone with?
On your phone. Yeah,
On your
people are sharing all of their
phone.
phone pictures of this comet. Unfortunately, I have a mountain that blocks my entire view to the west. So I'm going to have to get creative if I'm going to want to be able to
You
actually
need to
see
drive.
this comet. I'm going to have to go for a drive and get to the top of a different mountain that gives me a view out to the west.
So,
But
friend of our show, David Joseph Wesley, sent me a picture he took with his phone
yeah,
looking out across the LA basin with maximal light pollution, and it was gorgeous. So, do
yeah,
not say I live someplace too light polluted. You need to get out there and look at it as quickly as possible. Every night it's getting a little smaller, a little further from the sun, a little harder to see. Get out
yeah.
as soon as you can.
Totally. Now, before we get into this week's episode, I just want to sort of remind you how we make money. And that is sort of a couple of ways, but one of the main ways, and the way that we are relying on it more and more. I don't know about how your sources of funding are, but for the Universe Today media side of things, we're probably down 80% to 90% in advertising revenue than what we were, I don't know, 5 or 6 years ago. And so we're more and more reliant on Patreon at this point. In fact, I would shut Universe Today down if it wasn't for the patrons because of their support. And so I just want to remind you that, if you enjoy the content that we create here on Astronomy Cast, if you enjoy the work that we do over at Universe Today, if you enjoy the work that Pamela and the team are doing at CosmoQuest, those are 3 different Patreons that you can support to whatever ratio you think is appropriate. But we are getting to the point now in the media landscape where it's feast or famine, that with Patreon, we can continue showing up every day and do our jobs and produce all this content and communicate science to the world. Without it, we go get day jobs. What would your day? You'd be a programmer, wouldn't you?
Yeah, and I
Yeah.
really I can't sleep if there's a bug in my code. I should not work as a professional
Right.
programmer. I would never
I'd,
sleep again.
yeah, I'd probably be like a landscaper, I think.
You'd be happier than
Now.
me.
Maybe. I don't know. Anyway, so you can go to patreon.com/astronomycast to support this show. You can go to patreon.com/universe today to support the work that we do over at Universe Today. And then is it patreon.com/CosmoQuest?
X marks the science.
To directly support the CosmoQuest work that Pamela and her team are doing.
Yes.
And so if you've got a little money kicking around and you think that the work that we do is important and makes the world a better place, now more than ever would be a great time to support us. All right. Let's get into this week's episode. So it's time to talk about a different mission. This time, we're going to talk about the Neil Gehrels Swift Observatory, a NASA mission designed to help study gamma ray bursts. This space telescope was instrumental in studying the 2017 kilonova event, and it's still going strong nearly 20 years after its primary mission ended. And we'll talk about it in a second, but it's time for a break. And we're back. All right, Pamela. So I think, this mission, more than almost any others, is very personal for you.
It is. And as I'm thinking about it, I'm realizing this show probably exists because of this mission, which is a really strange thing to say. And it all comes down to the fact that we're here because both of us went to Phil Plait and said, "Hey, Phil, do you want to start a podcast?"
Yes.
And he told both of us, "Hell no." And then introduced us to each other.
Yeah.
And the reason that Phil and I were the kind of friends where I said, "Hey, do you want to do that?" is because I was collaborating with the American Association of Variable Star Observers, and he was part of the Swift team. And we were both trying to observe the things that go flicker and flare in the night, which Swift was discovering. So we're probably here because back in 2004, the Swift Telescope took off with Phil Plait as part of the team getting the word out.
That's crazy. Yeah. So without that telescope, we probably wouldn't be doing this show. So now this just became personal for all of you. So let's talk about this telescope. So I guess, what was the goal? What was the plan for the Swift Telescope? Why did they decide that this was the kind of mission that they needed?
So prior to launching Swift, we had very, very rarely been able to catch gamma ray burst afterglows. There'd been a few times where one went off, it was caught, and one of the problems that we really have with gamma rays is they are extremely difficult to focus. And so trying to figure out where on the sky a gamma ray burst went off was difficult, and we'd get maybe like it's somewhere within this square degree on the sky, and most telescopes don't have a square degree field of view, so trying to look for extremely faint and quickly fading away optical afterglows was extremely difficult. With the Swift telescope that got its name after the bird, the swift, and because the sucker is swift to get on target, the thinking was look in the gamma ray, look in the X-ray, look in the optical, going from it's over here somewhere to
Right.
it's within these dozens of arc minutes to it's within these 2 arc seconds to it's here.
Nailed it.
Yeah, with sub
Yeah.
arc second precision.
And I think, there aren't a lot of astronomical events that require that level of response. Like most of the time, there's a thing that's going on and, come back in a million years and it'll still be there. Maybe
Yeah.
it'll be a little bit
No big
different, but it's still, it's happening, right? But with gamma ray bursts, the sort of the most important parts of this event, the parts that will provide the keys to us understanding what they really are, this is happening within fractions of a second, and then within the first minute, and then within the first hour, and then they're fading away over the course of the next following weeks. And we just never had anyone go, gamma ray burst, okay, I got the first sub-minute
Yeah.
of observing it. So give us a sense of, you talked about how it has these different detectors. How quickly could Swift now put eyes on a target?
Seconds.
Yeah.
That was the wild thing about it is it was all happening in a matter of seconds. And then when this first happened, it was still in the days of pagers, people. Pagers were a thing. And
Right.
there were amateur astronomers who signed up for the Gamma Ray Burst Alert Network so that when Swift got its coordinates, they would receive a pager alert with coordinates so they could get on object as fast as possible to catch the light curve of these fading optical afterglows. And it was the kind of scenario where we actually saw folks looking to see, okay, so tonight the Swift telescope is going to look at this swath of the sky. So I'm going to look at variable stars. I'm going to do my astrophotography. I'm going to do whatever I'm planning to do in the exact same swath of the sky that Swift's in. As soon as it sees the gamma ray burst, it's going to do its toggle around thing to get it exactly lined up. I'm going to get the coordinates. I'll be on target in a minute. And now we, for the first time ever, are catching the first 10, 15 minutes, as in some cases, these things faded straight out of view of your sub-meter sized telescope. And by the time the object was no longer visible to the amateur astronomers, that's how long it would take to get a hold of the professional observatories and start getting these much slower moving multimeter telescopes on target. And so there was this amazing global response to gamma ray bursts going off, triggered by this one telescope. Well, these 3 telescopes on one spacecraft.
Right. But it wasn't just the finder scope for gamma ray bursts. It had a suite of instruments, or has a suite of instruments on board that allow it to also provide that first glance and the first analysis, giving that initial science. So let's talk about the kinds of observations that it's capable of making.
It is one of the few ultraviolet telescopes up there. And with its ultraviolet and optical system, it is capable of doing basic low-resolution spectroscopy. You're not going to use it to figure out isotopic ratios. You're going to use it to figure out rough redshifts of objects, to figure out generally where in our expanding universe they're lighting up from. It has amazing abilities to map out our sky in gamma ray, X-ray, and again, ultraviolet and optical. And so when we've needed these capacities to look in the ultraviolet, it's out there doing follow-up observations, targets of opportunity for scientists. It is a full-fledged astronomical telescope that just happens to be tied to a gamma ray burst alert system. And so one of my early career projects was studying Hanny's Vorwerp, where Swift was one of the telescopes that was used to help demonstrate that that galaxy near the Vorwerp is not currently producing ionizing radiation because we could observe in the ultraviolet.
Right. All right. We're going to talk about this some more, but it's time for another break. And we're back. So let's talk about, some of the major discoveries that were made with Swift, above and beyond your work, examining the lack of ionizing radiation coming from a galaxy near the Vorwerp. But what are some of the big, I mentioned one in the intro, but what were some of the really big discoveries and observations that Swift made?
So the first thing it did was it let us know that yes, there are gamma ray bursts going off every day, scattered across the entire sky, scattered across time, and that they come in multiple populations where there are the long duration ones, there are the short duration ones, and occasionally there's just some weird stuff going on. So in terms of the weird stuff, it's actually seen objects that burst for hundreds of seconds and then didn't appear to have an associated supernovae. So it seems that there are things out there that have insufficient composition to allow them to become a full-fledged supernova, which is kind of cool. We know distinctly there are the hypernovae related gamma ray bursts. One of the ideas of what's causing these are you have a supernova go off near a companion, you spin up a high density companion like a neutron star, it generates jets. We see those jets as the gamma ray burst. There's also you have an object that is already on its own doing all sorts of special things and it generates the jets. My bet is we're going to find it's a companion star. That's a different episode, however. But we figured out there are these longer duration ones that appear to be associated with hypernovae, and there are these super short duration ones. And the very first optical afterglow of one of these short duration ones was picked up by Swift. And then eventually we were able to realize with the 2017 LIGO, Virgo, Swift, everything else on the planet detection that involved roughly a third of the astronomical community.
Yeah.
We figured out it looks like sometimes you get the mergers of high density objects triggering gravitational wave releases, triggering gamma ray bursts of the shorter variety. These are those neutron star mergers. And Swift is part of that.
It is kind of amazing. Like gamma ray bursts was one of the topics that we covered early on in the age of astronomy cast. I'm sure it's sub 50, maybe even sub 30, maybe sub 10. I don't know. But yeah, you can definitely go and find our earliest gamma ray burst episodes. We talk about the history of discovering them with satellites designed to detect nuclear detonations on Earth. But when we recorded that show back 17 years ago, I sort of think about our mindset back then. Like, what did we know? We knew that there were these very bright events that happened where more energy than the entire galaxy was released into the universe, and probably like a collimated beam was being directed at Earth, and we were staring down the barrel of a beam. And that's all we kind of knew. What caused them? Right? Are there different varieties? No, don't really know. And here we are, where we know that there are long and short, that the long ones, there are various causes, but they are probably due to an extremely massive star collapsing, like detonating and creating a, as you say, hypernova, a next level supernova. And then there are the short varieties, and the short varieties seem to be colliding, merging, degenerate objects
Yeah.
like neutron star, neutron star, neutron star, white dwarf, neutron star, black hole, and that whole story has unfolded during our tenure here on Astronomy Cast, going from really almost no understanding to where we are now, a fairly sophisticated understanding of it. And I think so much of that is just Swift. Thanks, Swift.
And one of my favorite things that it's allowed us to do is, as it's been finding the nearest, the farthest, all the different descriptors of gamma ray bursts, in one case, it actually caught a fairly nearby object emitting gamma rays right before it went supernova. So we, for the first time ever, were able to say gamma rays come out first when supernovae are occurring. And then we caught the entire story of that particular weirdo supernova as it went off in a relatively nearby galaxy. And this kind of detailed physics was never possible before. And we are catching as you said before, the rare objects that aren't doing their thing for millions of years. We are catching them in real time as they undergo amazing explosions and nuclear reactions.
All right, we're going to continue this conversation, but it is time for another break. So let's talk about the spacecraft itself. I mentioned in the introduction that it had its primary mission that was 2 years long. We are now here in 2024. How long has this mission been operating for?
It went up in 2004. It was supposed to live through 2006. We are recording this in 2024.
Right.
So this is one of the most fabulous cases of NASA engineers going, 2 years, I got you. How about 20 instead? And
how about forever?
Yeah. And what gets me is, in preparing for this episode, I was looking for some of the visualizations and stuff I remember from the early days, because there's this amazing visualization that came out of Sonoma State University that allowed you to see scattered across the sky where gamma ray bursts had gone off, and then they'd fade in how they appeared in the visualization as time passed. And you could literally see how the sky was changing as seen by Swift. And the telescope outlived the web page.
Right.
And
which is a whole separate issue, right? That we are losing our history. That you've got that's not the only one. I mean, I run this all the time when I'm looking for historical information on various missions and programs and projects and teams and labs and all this kind of stuff. And a bunch of enthusiastic go-getters put together a web page and talk about their mission, and then the mission gets canceled, and then the funding for their web page ends, and then the web page dies, and the link rot continues, and we don't even have it. Someone should be pounding information about Swift into Sumerian tablets, into clay tablets, so that it will last for thousands of years.
And one of the things that got me about this one is, way back in the early days of social media, when it was MySpace, it was the Swift Telescope and GLAST, which later got renamed to Fermi, that were bantering back and forth and were the first example of NASA missions showing personality. It was Swift and GLAST, which became Fermi, that paved the way to see Phoenix Lander break our hearts, that paved the way for Solar Dynamic Orbiter to have a chicken as a mascot. And
right. Yeah, you were pretty into that.
So all these different things that have allowed us to fall in love with spacecraft over and over and over again started from MySpace pages that I absolutely could not find when I looked earlier today.
So we are now at, I don't know if you notice this, we have crossed 1,000 gamma ray burst detections
Yes.
from Swift, which
Yes.
is crazy.
And yeah, and it's been a few years, and as it just keeps doing its thing, one of the bits of science we have to be super grateful for is there is no replacement currently being planned.
Mhm. That was going to be one of my questions, right? Like,
Yeah.
okay, we're at 20 years. What comes next? What's the replacement? What's the plan,
Yeah.
NASA? Yeah.
And this is where
Keep Swift going.
So the National Academies of Science recently put out a document on the status of NASA, where they pointed out that roughly 80% of NASA's infrastructure is well beyond its planned life expectancy. And there aren't always things to replace them because there's only so much money. There is a giant planned mission to go to the moon that is vacuuming up funds. There was a giant planned mission to launch JWST that ate a lot of funds. There's always some big thing coming. And so Swift, we have to be so grateful. It is still healthy. It is still doing its job. It is still producing amazing science across 4 different major parts of the electromagnetic spectrum. And there was a scare earlier this year with its gyroscopes, and they were able to luckily reprogram things, throw it into a 2-gyroscope mode. And may
don't even
those
say the
2
word
gyroscopes just, say the thing you always say.
Well, you always need more gyroscopes.
You always need more gyroscopes.
Yeah. Now the name we mentioned, it's the Neil Gehrels Swift Telescope. That name is actually relatively new. It had always been the Swift Telescope until 2018.
Right. So Niels Gehrels was the original principal investigator for this mission. He was the human who chaperoned it from original conception through to launch to figuring out how to make the most out of its data. And when he passed away in 2017, the idea of renaming the telescope, well, it began to take shape. And in 2018, we saw the mission get renamed. And next week, we'll be talking about this researcher who allowed all this innovative outreach and science to both take place across decades.
Well, that sounds great. It's a cliffhanger for next week.
Is.
Thanks, Pamela.
And thank you, Fraser. And I had the window open to thank the humans, and then I closed it in my fury to stop the duplication of voices. Okay, I got it. Sorry, Rich. And okay, starting the sentence over. Thank you, Fraser, and thank you to all the folks out there who are already supporting us through Patreon at patreon.com/astronomycast. This week, we'd like to thank the following $10 and up patrons: Abraham Kirchell, Adam Anise Brown, Antisaur, Arctic Fox, Bart Flaherty, Bebop Apocalypse, Benjamin Carrier, Bob Krell, Brett Mormon, Smansky, Claudia Mastriani, Cooper, Daniel Donaldson, David Gates, David Truog, Dwight Ilk, Frederick Salvo, Frank Stewart, Galactic President Scooper Star McScoopsalot, Georgie Ivanov, Gerhard Schweitzer, J. Alex Anderson, James Roger, Janelle, Jarvis Earl, John Baptiste Martinet, Jeanette Wink, Jim McGeehan, Jimmy Drake, Justin Proctor, Katie Byrne, Keith Murray, Kellyanne and David Parker, Kim Barron, Les Howard, Mark Schneider, Masa Haleu, Matthias Hayden, MHW 1961 Supersymmetrical, Michael Hartford, Nate Detweiler, Paul D. Disney, Pauline Midlink, Philip Walker, Robbie the Dog with the Dot, Ron Thorson, Scott Briggs, Semyon Torfison, Siggi Kemmler, Tim Garish, Wanderer M101, and William Andrews. Thank you all so very much. And if you too would like to hear me struggle to pronounce your name, join us at patreon.com/astronomycast.
Thanks, everyone, and we'll see you next week.
Bye-bye. And then they saved.
And they saved.
And
That's
this
what they did.
week, I will save in the correct directory, which I did not do last week.
Yeah, did Rich not appreciate your trying to mix things up a bit?
I worried him because he did not have access to where I saved the file.
Yeah.
Luckily, other humans did, and Allie, as so often happens, rescued me. So thank you to folks over on Twitch. Alan Gross is currently on a 3-stream streak. Thank you. And Ambius, thank you for 28 months of subbing. And thank you, Malachi, for interrupting the stream with a sneeze.
Okay, so 2 days ago, we watched a rocket land and get caught
It didn't
by
land,
a giant
it got caught.
launch tower.
Yeah, it was spicy. It was super spicy.
You know, everyone I've talked to has been almost a loss for words to talk about their experiences and what they saw and how they feel about this. How do you feel?
I feel many things. And the reason I feel many things is the FAA gave them a very precisely worded launch license that basically said, we give you permission and you're responsible for making sure everyone else gives you permission. And they did not have permission from the Texas Commission for Environmental Quality. So they broke their launch license, which means they're in jeopardy of further penalties and not getting future launch licenses. And so it's one of these things of, you did something so cool, but because you refused to wait, you jeopardized your future. Why did you do that?
Right, because this could come back to haunt them.
Exactly. And their deluge system sprayed water beyond what they were allowed to do, and the oxygen vapor covered a vast swath of wetlands in a region of death. And so I'm like, this is such amazing technology. Can you please not destroy our planet? I want you to succeed, but be kind. And the combination of conflicting emotions, thoughts, and ideas made me angry that the Mojave Desert isn't next to the Gulf of Mexico and that they didn't wait. And yeah, I have thoughts and I'm going to have to write, and I have many thoughts.
Why the Mojave Desert?
Because they're not going to kill a whole bunch of things that are in a wetland if they're launching from a salt flat like everyone else does.
Right.
Yeah, they're in the middle of a nature preserve, and NASA's also in the middle of a nature preserve with Kennedy.
Yes.
But they're really good at like confining their deadly chemicals and overabundance of oxygen and things like that to not on national wetlands.
But okay.
So I have all the conflicting thoughts. Amazing technology. We need them to succeed. They are 3 years behind schedule for Artemis. Please hurry and catch up to what you promised you were going to do. You are getting there. That was a very spicy landing where you melted a good deal of your spacecraft. Please don't do that next time. But you caught it, which is amazing.
Yep.
And then
badness. Both the super heavy as it was coming through. I mean, you could peek under the rocket fairing down at the bottom and just see, or the engine fairing, and see this sort of glowing yellow underneath spicy. Where all of these, spicy, where all of these rocket nozzles were starting to get super heated, and you could just imagine getting deformed and ablated and stuff falling down. And yet the thing held together, and that sort of final maneuver as it came into the launch tower and was sort of dancing with the tower, going, okay, can we do this? And then it was like, yup. And so then it did this little kick sideways, put itself into position, and then landed with a level of accuracy that's just, it's stunning. And when you look at it from the top, you see what look like it's being held by the grid fins, but in fact, it's these big pins that are
Yeah.
coming out of the side of the top of the Super Heavy, and like there must have been inches tolerance for it to be able to land like that and be
Yeah.
grabbed, and then you saw it sort of push down with the shock absorbers of Mechazilla to be able to hold it
Yeah.
in place. And yeah, you say spicy, yeah, for sure you could see sort of explosions and fire coming off the bottom of the thing as it was wrapping up its landing. And then on the flip side, we saw Starship, right?
Yeah, it did
Coming
not
through the
survive.
atmosphere. Well, no, but the chef's kiss was the switch to the buoy showing it landing. And
Right.
so they knew they landed with so much precision. They landed exactly in front of their camera
Yes.
so that they could show off the landing. And again, that was incredible. And so when you look at the to-do list of the stuff where you're like, we might need magic to overcome this, that list is
Yes.
getting a lot shorter now.
I'm just really hoping that, I mean, they have such a solid tradition now of going against the Clean Water Act that it's worrisome, and I don't want them to lose their ability to keep going.
Mm-hmm. Do
Yeah.
you think they will?
I think they could so there's a few different things happening. We have people at the FAA getting their lives threatened for not authorizing things
Mhm.
fast enough. It has been made a political issue with the presidential campaign, where there was concern going into this that if the FAA held their ground and didn't put forward the launch license until the Texas Environmental Commission had finished their period of public comment, that the FAA would be accused of election interference.
Mhm.
All of this shit should not be happening. And so I really worry that this is becoming more of a political issue than a technological issue at a certain level. And when something becomes political, weird stuff can occur. And you never know what direction the weird stuff is going to go in. So, yeah, I don't.
Yeah, but
we've entered the land of chaos and people's lives being threatened, which I'm not okay with.
no, but I feel like you can count on giant corporations getting what they want in the end.
Yeah, and I don't like that.
No, but I think what you seem to think that sturdy government employees are going to stand fast against the demands of a multi-billion-dollar organization that has been tasked by a different government agency to accomplish a goal.
This is why all last week I simply kept going, I am so confused. Yeah. So one of the things that's on my to-do list is to try and figure out who to reach out to in the Artemis program for comment. Yeah.
Yeah. Because I mean, in this case, the need for Starship to be part of the critical path is getting more and more acute, and we may get to a point. I think we will inevitably get to a point where Starship is the thing that is holding up Artemis.
We are already at that point because
Yes.
Artemis 3 is on schedule. And so, yeah, we're already at that point. And so the question now becomes, is New Shepard going to actually, is it New Shepard or New Glenn? Is
New Glenn.
the Blue heavy lift going to successfully launch in the spring? And
Yeah.
will the Blue Origin lander, which is much simpler technology, will it be able to leapfrog Starship? Because based on analysis of how long it's going to take to fuel up the Starship on orbit, Blue Origin's going to be done first.
I wouldn't say that. Come on. I mean,
You've seen Dustin's video.
You're living in competing FOMO here, I think. where it's a three body FOMO where you've got, on the one hand, you've got NASA that says we've built this space launch system, we've
Yeah.
tested a flight to going around the moon, we're going to be sending humans to around the moon in 2025.
Yeah.
We're going to send this gigantic rocket towards the moon in 2026.
Mm-hmm.
Let's hope that all of our other partners are going to fulfill their components of this.
2026 isn't going to be done by
But
anybody.
I don't think that NASA is going to be the one that's going to be slowing down this process. And then on the other hand, you've got Blue Origin going, wait, guys, we want to be part of this too.
Mm-hmm.
And like, how long has Blue Origin been working on New Glenn in secret, over time, over budget, not showing us anything? We're like a decade into this? I don't know what the numbers are, but it's crazy how long we've been waiting. And Blue Origin continues to crank away in secret and hasn't really shown us anything that functions. So I don't think you can.
The question that we have is Blue Origin going to pull off the "it just works" that SLS pulled off, which still baffles me, or is it going to require multiple iterations?
Yeah, is it the beginning of the SpaceX type testing regime?
And this is what we don't know.
Yep.
And if Blue Origin pulls off the traditional "it just works" that we saw from so many different NASA rockets,
and even Vulcan,
and
Ariane 6,
yeah,
and Vega 2, and all of the like that's the traditional ways you launch your rocket the first time, and the expectation is the thing's going to work because you engineered it properly and it's just going to go. And the SpaceX way is we're just going to keep trying and learn a ton.
We're going to do iterative design with agile processes, and so we don't. As I said, the most common phrase I said last week is "I am so confused."
Yes.
And so I feel like the time, having watched Dustin's video on Smarter Every Day, I feel like it's going to take forever to figure out how to fuel on orbit and get everything fueled and complete the test landing without humans and be ready for the landing with humans with Starship. And so I feel like if Blue Origin pulls off the "it just works" over time, over budget, in the tradition of big government rockets, they will leapfrog because they don't have that refueling process to innovate.
But then they've got to build the lander, which is a whole separate. I mean, they're already contracted to provide the lander for like Artemis 6, I think. 5.
I think it's 5.
Yeah, so we get like 2 missions with Starship, and then Blue Origin is providing the next lander. And yet all of this is happening while the Chinese have put their plan into place and have put their timeline together, and they're hitting their milestones with
They're going to get there first.
They're going to I don't think they're going to get there first.
Really?
But I think but I wouldn't be surprised if in the end it is a race down to the wire with some US, whether it is the plan right now, the Artemis 3 plan, or whether it's going to be some combo of Blue Origin or whatever, that it will shift. And I think, the political pressure to land before the Chinese land will be too great. And so I think you're seeing this now, that I think on the one hand, you've got holy cow, that was that things are moving forward in a way that is, environmentally concerning. And yet seems to be, this is the path that NASA and the US government have decided upon. And so they're going to be pressuring to make these problems go away and make this launch.
So
give them the room to do their tests at the pace they want to do them.
My stomach is often exceedingly wrong on many things, including what I should eat. Right. But my stomach, which is a lying liar,
Yeah.
feels that SpaceX is going to end up having to move to using their KSC facilities and stop using their Boca Chica facilities due to the lawsuits going on.
Hmm.
That's kind of what I foresee is they'll be able to keep going, but a jump between locations is going to be
Right.
required.
Which will be, I mean, they'll be, they're
It's just
already building up
delays.
all the infrastructure. I mean, I don't even know how much delay there is. I mean, they're building up all this infrastructure at Kennedy Space Center. This has always been the plan, is that
Yeah.
they're going to launch all these things from Kennedy Space Center as well as Boca Chica. So, but yeah, so I totally get, like I feel this kind of ambivalence and anxiety about the state of this whole process right now with
Yeah.
Blue Origin isn't ready. SpaceX has some big things that they need to overcome.
And weird shit. Did you see the Cards Against Humanity lawsuit?
Yep.
So for those who don't know about this, for whatever reason, SpaceX put a whole bunch of their stuff, including a bunch of buildings, on Cards Against Humanity's property. It's like,
Right.
why? Why did you do that, SpaceX? Again, things that caused me to say I am so confused.
Yeah. And so we're not going to see a clear path out the other end. And I don't think, like, what are your choices? Your choices are put all your cards on Blue Origin. Well, that means wait 20 years, right? For them to work in secret and maybe or maybe not deliver. Like that doesn't make sense. Okay. Build the SLS. Well, SLS costs $4 billion a launch. They've already put in tens of billions of dollars in investment.
Yeah.
It is unsustainable to build a rocket program around SLS, and it doesn't have a lander. That's not a good plan. Count on SpaceX. Well, SpaceX does get there. They often take longer than you expect, and the final product doesn't necessarily meet what was the initial promise. And so there's no good path.
No.
And then, like, don't do anything
Is not a viable path.
is not an
either.
option either, because then the Chinese are going to get there before you and start to consume more and more of the launch market. And so there is no good solution right now. They're all nasty. And if I was in a position of leadership in one of these organizations, I would be really uncomfortable with the suite of options arrayed in front of me.
I was doing an interview last week off the record with someone who's in the know for a lot of the lunar stuff. And they were saying that, like, if they had their way, like, burn it all down, start NASA over from scratch, fire everyone over 50. I may have gasped a little as a 50-year-old.
Yeah.
And redesign it for the new space race. And it's hard to know how much of what we're dealing with is Congress and NASA and those evaluating it through the national academies don't know how to view the space race given modern technology, versus we still don't understand so much of what's going on with the environment, with blowing a hole in the ionosphere when you blow up super heavy in it. There's just so many different unknowns on the economics, on the environmental issues, on the what companies are going to be capable of functioning under fixed contract budgets. Everything is new and weird, and I don't think anyone fully understands how to make plans in this new environment. And then the budget is so restricted.
Yes, right. And yet they're not giving the money
Right.
to figure this out, to come up with an appropriate response to the demands that they have. And so we are just trapped in this weird ambivalent anxiety of watching this whole thing go forward when it's like there's a laudable goal. Let's have humans walk on the moon. Let's extend humanity to become a true solar system spanning civilization. Let's know that we can look up at the moon and know that there is now a permanent station on the moon where people are living and working and like the International Space Station. I mean, I don't know how you feel, but every time I see the space station go overhead, I'm like, there are more than 12 people on that station right now.
There are 10
Human beings
toilets in space.
Yeah, human beings have been continuously in space now since 1999.
Yeah.
And that has never stopped happening, and I don't think that should ever stop happening. And hopefully soon there will be humans in orbit, and there will be humans on the moon, and then there will be humans on Mars, and there'll be humans at the asteroid belt, and this will be just this continued presence expanding across the solar system.
Yeah.
And yet
We need
the
to figure
budget.
out how to do it without destroying our own planet.
Mhm.
And it's just tricky. It's
Well,
one of the hardest problems we're going to have to figure out.
yeah, I mean, I think that we take the destroy our own planet path all the time,
Yeah.
right? Like,
We need to
people drive
stop
cars.
though.
People, well, sure, but where to start?
Yeah.
People drive cars. People order goods from halfway across the world. People take flights to Iceland and Amsterdam to for a fun vacation with their kid.
Yeah.
People, right? Like
Yeah.
we live in this mindset, both at a government level and at a personal level, of essentially denial of what we're doing to the planet and where we exist right now. And yet the laws of nature, the environment itself, will push back and have the most powerful hurricane ever seen in recent memory just appear out of nowhere in the middle of the Gulf of Mexico. That kind of thing, until people wake up. So, I think the anxiety that you face about what we're doing to the planet is, feeding into, it's your lens now that you're looking at everything that is
Well,
happening, right?
so it's one of these things where I've talked about it before. Back in 2003, I was reading papers that said when the following thing happens in the ocean, we will see the following things start to melt and the following effects occur. And we're now seeing that.
Yep.
There was, back in 2010, there were papers that came out that were talking about if the launch frequency gets to a daily cadence, if we start destroying this many things in the upper atmosphere, we're going to start experiencing these things. And I don't want the predictions of those papers to also come true. And we're starting to see the research coming out of dumping this many aerosols into the upper atmosphere is going to increase the green. And yeah, we live in the dangerous place where it is our job as journalists to bear witness to what is happening in science. And that includes what's happening in environmental science. And to have that vantage point of seeing both this technology is amazing, as well as I understand climate change more than I would like. And being a journalist and bearing witness to both sides is a really difficult place to be.
Mm-hmm. Yep. Yeah. And I think you often have to, like, hive off different parts of your brain sometimes. Like, you kind of have to just go, I'm just talking about the science right now.
Yes.
Right. And sometimes the science is helping us understand the state of our climate. And sometimes you just have to, because I think you could, you talk about AI, you talk about all of these kinds of things, and each one turns into a giant environmental rabbit hole that you could then proceed down, right? You're like, I ate lunch today. Well, like, where did you lunch? What did you eat? What is the greenhouse effect impact of the meat that you ate?
I did not have meat.
Well, when you do eat meat, you are causing a larger greenhouse impact, gas impact than, than someone who has chosen a plant-based lifestyle. And so we live in these all the time. And I think part of the problem is that just the government has given up trying to really deeply put giant corporations feet to the fire to make sure that they help clean up the emissions that they're causing,
Yeah.
and instead have allowed the corporations to brainwash us into thinking that it's our fault.
Yeah.
And that if only we just take, lower our personal carbon footprint. And
It
if we
has
don't,
no
if we
effect
can't,
compared to these mega corporations.
yeah. So I think, back to the idea of externalities, that if a corporation wants to earn a profit by extracting carbon dioxide, releasing stuff from the ground, then they have to figure out how they're going to pull that carbon dioxide back out of the atmosphere before they earn a profit from the work that they do. And if it makes it too expensive or makes the cost of their things higher, then so be it. And we're not there yet. And so back to rockets, in the sort of the dream world. I mean, one of the amazing possible things about Starship is that it is methane powered. You can produce methane by a chemical process, turning water and carbon dioxide that you pull out of the atmosphere using solar power to generate methane out of nothing. And you could be carbon neutral, but also you could just go down to the store and buy methane, please. So, but anyway, wasn't it amazing to watch a skyscraper get caught by a skyscraper?
I felt all the emotions, every single one of them, all of them.
And is a skyscraper that
catches skyscrapers,
reuses its fuel
spicy
a better environmental impact than a gigantic rocket that is completely destroyed with every launch?
It depends on what they release and what they ablate at what level. I don't think we've run all the numbers yet. So.
And then how does the methane use of a giant skyscraper rocket compare to the methane use of a container ship that brings lawn gnomes from China over to New York?
Yeah.
So anyway, that's food for thought, but we've reached the end of our hour. And so it's time to go. But thank you. So I've got an episode coming out in moments where I go over the launch with Scott Manley and Marcus House, the fifth time that we have done this analysis, and we go into great detail and hopefully provide not the level of environmental sadness that has been expressed in this episode of Astronomy Cast, a more enthusiastic, gobsmacked side of the engineering involved. But I think you'll all really enjoy that. And then my question show is coming out a day late, so we're going to be releasing that tomorrow. And then I'm going to be doing a universal time stream. I think that's the name. And so I'm going to do an episode of my QA of my live show that is appropriate for Europeans.
Nice.
Yeah. They're people too.
When we are done recording this, I am going to change into something that green screens slightly better, because I'm noticing I'm having green screening issues, and record Escape Velocity Space News, which should go live to patrons on Wednesday and will premiere on YouTube Saturday. This weekend, we are celebrating 15 years of 365 days of astronomy.
Whoa.
Yeah. And so we're going to be working to raise funding to keep it going into year 16. And I'm going to drop into Twitter we are looking for people to do just like they did back in 2009 and sponsor a day of the show with a $45 donation.
I like that idea.
And this is your chance to get me to say this episode of 365 Days of Astronomy is dedicated to that science teacher that meant the world to you, to that aunt that took you out and taught you how to use a telescope, and
to that dog that just fills your life. Yep.
Exactly. So this is your chance to sponsor science, do a shout out to someone that matters to you, and be part of all of it. Please do not explode at me, YouTube. I'm going to hit the button there. I hit it before it could start making noise. I'm dropping the link into the YouTube chat.
Okay.
So,
all right.
Go sponsor you. We're going to go off. We're going to have an awesome day, and can't wait to see your next episode.
All right. We'll see you later.
Bye-bye.